All right, part 2 of the same word problems here. So here's what's wrong with those equal signs. This is from a 9th grader. If you too want your questions answered, you can text your question to math to tube, and you will get a YouTube answer back. All right, let's get started. All right, so what's wrong with this one? Let's take a look. This one, it seems like it makes sense. There's adding sign, and this square and with this radical here should be able to cancel. I should just get my x out. This is such a typical example of what happens to my students. Now, the big reason why this is not true is from the order of operations. As we know, the order of operations, it says please, excuse, multiply, divide, add, and subtract. Please excuse my dear Aunt Sally. I'm sure you heard this one before. The reason I have it going up and down is that I want to show you that in a triangle form, there's a hierarchy of operations. Okay, let's bring that triangle back in again. Make it a little bit bigger here. Okay, so please excuse my multiplication, division, and Sally. Okay, so over here, adding is way on the bottom. As you can see, the ladder, the importance of operation, the order of operation, adding is way down the bottom. Exponential and the radicals is actually counted over here. When they cross a class, a gap here, you can't just split them up. Like when A times B with the radical, now times is here, right? They're right against each other. You see the order operation. For this one, you do this, you can split it up. So just make sure each one carries its own roof. But when you're dealing with adding, you can't do that. Okay, it does not equal to A plus B. A very simple case is this. If you have a 1 plus 1, okay, this really is equal to radical 2. And if you use your calculator, you'll see this is 0.1414. Now, if you were doing the wrong way, let's change into the alpha green color, you'll see this does not equal to radical 1 plus radical 1. Okay, because this is really equal to 2, right? And 2 does not equal to 1.414, not even close, right? All right, so how do we fix this one? Let's go back and take a look at it. When we have an adding, remember, and the radical here, we can't cross boundary. So there is nothing you can simplify on this one. This is as simple as it gets, right? Now let's see, we don't have a lot of time, so let's take a look at this one. What's wrong with this one? Anything cubed, it's really itself duplicated 3 times. Okay, so if you were to write this one out, well, you really have, so how many do you have? 1, 2, 3, 4, 5, 6. This is really equal to x to the 6. So basically, when you have multiplication here, you literally do 2 times 3. Now this one is not true because x squared times x third. Now that's equal to x2 plus 3, or x to the 5th. Okay, but notice here I have 2 base, right? X and x. Here I only have 1 base. When you have only 1 base multiplication, you leave it alone, you just multiply. Again, by itself, 1 base, just have a multiplication. You don't do anything fancy. Just combine those 2, multiply it. Worst come to worst, repeat this process. You'll see it's equal to x to the 6. All right, have a confident day.